This is the Tornado Trackers podcast. The Tornado Trackers are storm chasers Jeremy Heyman, Jeff Mangum, and me, Gabe Cox.
Hey, I'm Jeremy.
I'm Gabe.
And I'm Jeff.
Welcome to the Tornado Trackers podcast. It's so awesome to have y'all here. We are super excited for the show tonight. We have a fabulous guest that we are so excited to introduce you. But first, something fun in our lives in podcast land. I don't know if this will date us, but this is our first record after launching the podcast into the world. This is a peek behind the curtain. And so it feels like we've just smashed the bottle of champagne against the big boat and pushed it out into the water, and we're getting some feedback, and it's so awesome and so exciting to just hear from everyone that's listening. And yeah, it just feels pretty incredible. How are you guys feeling?
Yeah, it was an exciting day yesterday getting it launched and then seeing everyone's reactions to it. It's been well received. I'm really excited to be doing this. Yeah,
it's been a long time coming, and this is just such a fun thing that us three best friends get to do together, and we're just so excited to bring all these storm stories to all of you out there. And I've already had so many people come back with their own storm stories. People just want to talk about weather, like it's considered quote unquote small talk, right? But it's interesting. Yeah. It's fascinating. And there's always an emotion or a narrative behind these things that happen to us that just, come over the horizon and change our lives. So we're pretty stoked to be here with y'all. So thank you so much for joining us along the ride. So, well, with that, let me introduce our guest for our podcast tonight. Dr. Karen Kosiba is an adjunct research professor at the University of Illinois. She has a BS in physics from Loyola University, an MS in physics, and an MAT in teacher education from Miami University, and, no big deal, a PhD in atmospheric science from Purdue University. Dr. Kosiba is a strong believer in experiencing weather from the inside of a mobile weather radar. We're going to get into that a little bit more if you don't know what that is. She has participated as a radar operator, a project scientist, and a project leader in a multitude of scientific field projects utilizing the Doppler on wheels, for studying tornadoes, hurricanes, and so much more. Ladies and gentlemen, welcome to the podcast, the amazing Dr. Karen Kosiba. Welcome, Doctor.
Hi.
It's so great to have you on the show.
Yeah,
Thanks for joining us.
Yeah.
We're so happy to have you here. We've been following you for a while on Twitter, and you came into at least my consciousness. I think we all read the story that I think it was Hurricane Laura that the Washington Post followed you. And these guys were there as well. Not the same place as you were, but we were just like, oh wow, Dr. Kosiba was in the Dow, in her truck, in the eye, and that's amazing. And we really want to talk about that for sure. That experience. I don't know what that number hurricane that is for you, but maybe it's old hat to you, but
no, hurricanes are never old hat.
I bet. Yeah, absolutely. But before we get to that, something we like to ask all of our guests is what made you in terms of weather? I think, like we said before, everyone has a weather story, right? Or a story that kind of kicks around their family about the great snowstorm, that they experienced way back when. But I feel like us weather people, right? We have a circuit that we're pre-programmed with, that an experience happens maybe when we're younger, and that circuit gets flipped, and we transform into, the weather fanatic that we are. So I'm curious, what is the weather story for you that made you who you are today?
I'd like to say I'm a late bloomer.
Great.
Yeah. So I was about 28 when
Nice.
I thought, no, weather should be something I should study. I don't have a good weather story. I really do feel like, I don't know, I just never settled on anything. And I don't know. I mean, it's not like I never didn't like weather. But I think it's sort of, I was going through school and stuff, and I'm sort of like, oh, what do I want to do with my life?
Yeah. Did you have like a professor or anybody that like inspired you or anything like that? Or what kind of made it interesting to you?
No, I kind of liked physics, and I really didn't know what I wanted to do. So I just like kept taking classes and doing stuff. And no, I mean, I had a lot of good professors, a couple in college, but then in graduate school. And then certainly after that, I've had influential people. But I think ultimately, I mean, I've always been afraid of tornadoes and weather. Mm-hmm. So I actually had a really bad time when I was just afraid of tornadoes, like really afraid. And I think that probably sparked my interest in being like, well, how do they form and how often do they happen? And what are the winds really like inside them?
Totally.
And yeah. And
then that's a normal person. Yeah. That's what a normal person feels like.
That's a healthy fear. Yeah.
Yeah. It's a healthy fear. Yeah.
Yeah. I really relate with that too. That's kind of my weather story too, is I grew up like, obviously we're not the same person or with the same experience, but I grew up in the Midwest, pretty freaked out by the storm sirens and tornadoes, and wish somebody would have explained to me, how these things form. This is, a natural phenomenon that's happening. Where did you...
Oh, sorry, go ahead.
Yeah, where'd you grow up?
I grew up in the Chicago area.
Okay.
Yeah.
But I was gonna say, the one thing, like, I never feel like they teach weather or anything like that in school, or if they did, I, feel like I missed that month of weather class. And like, I don't feel like it was ever anything like that, you're sort of taught, like, as you go through school. It's kind of like, oh yeah, there's clouds and that's about it. There's the water cycle, but never like really like, the nitty gritty of, understanding weather or specific types
So
of
what
phenomena.
was the journey then from fear of tornadoes to now you have a PhD in atmospheric science? How did you get from point A to point B?
I don't know. Like,
It's all a blur.
I love that answer so much.
I'm like, I don't know. You just kind of keep doing things you like, and you keep working with people you like. And I was really afraid. And when I was in graduate school, getting my master's, I was doing laboratory modeling of tornadoes. And at some point, I had to graduate and decide what to do after that. And I think I was feeling better, more confident, but I still, at that point, I think I really wanted to go on and, study tornadoes, but not necessarily in the laboratory or on the computer. Or, doing computer modeling, I should say, because I'm always in front of a computer.
The computer modeling and things we've talked about a little bit previously in other episodes. Just for like the layman out there, what kind of walk us through, like explain to us, like we're 5 years old, what kind of computer modeling of storms, what does that even mean, or what does that look like?
Yeah, I mean, it means different things. I mean, so when you're doing tornado computer modeling, I mean, I guess modeling all is sort of the same thing, where you're using numerical formulas and putting stuff together in a computer. No, you're using numerical formulas to solve different parts of the atmosphere, and trying to see what the winds or the temperature and stuff like that's like. You're trying to model a storm or a likeness of a storm, or a bigger scale. For tornadoes, and I mean, recently, again, this will age me a little bit, a lot of what you have to do is called this large eddy simulation modeling, which means that you can't really represent the storm because it just takes too much computer power to do it at that scale. So what you're really looking at is just the tornado, and you're looking at, obviously, some idealization of what a tornado would be like in a numerical model. So it's just in that case, it's a really small scale model. And a lot of times, like I said, you're neglecting the storm, and also a lot of times you're neglecting the thermodynamics. So you're really just looking at vortices in that sense.
Wow.
Interesting. So then what took you from computer modeling instead? So you wanted to get out of a office building in front of a computer to in a truck in front of a computer.
Totally different.
How was that journey, and what got you interested in the Doppler on wheels? And
so when I was doing my PhD, I was working with Jeff Trapp, who also is at the University of Illinois. So circled back to that.
Chicago.
But I really just wanted to get out in the field, and he knew several people that were doing field stuff with radars. So both of them were at the University of Oklahoma, Howie Bluestein and Josh Werman. And Josh Werman was the one that's like, hey, yeah, whatever. So I always joke, I'm like, come on, I really wanted to go with Howie. I'm like, and I got you instead. But yeah, so I went out in 2004 for the first time with the radar trucks and drove down some dirt road and never saw a tornado for weeks and weeks. And then quickly after that, they were looking for people to do a hurricane missions in the fall of 2004. And I'm like, sure. Like, and I really I knew nothing about hurricanes other than like what lame, I mean, I had not studied hurricanes. I mean, that was not all my area of expertise. And I didn't even think about how you'd get data in a hurricane.
Yeah.
So it was like, sure, yeah, whatever. And then I'm like, oh. So.
Eye-opening.
Yeah.
What hurricane was that?
Hurricane Francis. Like I said, I didn't know what to expect. I sort of like, I had emailed back and I'm like, what do I expect? And he's like, I don't know, just pretend you're camping. What would you bring camping? And I'm like,
Yeah, that's totally what it is.
And I'm like, I guess a sleeping bag. I'm like, putting all this stuff together. And then like, I'm down there and like, it's like weird, obviously in a hurricane zone, everything's like closing up and boarding up. And it's sort of desperate too, because not everybody's evacuating and the people who can and can't. And then we did it. And I was in the truck with his graduate student, I remember. And then they were in it, and Josh and everybody else was in a different truck. And the way we had parked, it was sort of like on a cliff. There's no other nicer way to say that. And we have the legs that go down on the radars. And so hurricanes always seem to make landfall at night. And like the whole night, I was totally freaked out. So I'm sure there's some blackmail video somebody has from me somewhere in this. But like... yeah, we just can never level the whole night, So, and I'm like, how come we can't level? How come the truck doesn't level? And his graduate student's like, don't worry, it's fine. Don't worry. This is what hurricanes are like, And I would just like the whole night. And then like the driver opened the door in the middle of the hurricane and like torqued the door and like all of our stuff flew out. Yeah. And I'm like, but I think that was his first hurricane too. Because he didn't want to go to the bathroom inside the truck, obviously. And then... And then we had called over to the other truck sometime because I think we were feeling worried about something. And then they were like, we're on fire. We can't talk to you now. Bye. We're like, okay.
Wow.
So we're just like sitting there and it's dark. Yeah. We're like, oh my God, what's going on? And then morning came and they had put out their fire. It was just a small little fire. And our leg was actually just hanging off the cliff.
Oh my
God.
So it had no ground underneath. So I was like, vindicated.
Yeah.
You're like, he was right.
Yes, I'm
Your
like,
feeling
yes, something
was
was wrong. Yeah, but yeah, so I was like, oh, and then after that, I'm like, okay, I don't want to do hurricane missions anymore. And I'm like, if I do, it's not going to be on a bridge, a barrier island, or a beach. So we were on or a cliff or something. I had some 3 Bs that I wouldn't do. So then for several years, every time they'd ask for a hurricane mission, I'm like, no, thank you.
So for people who don't know, could you explain the DAOs, the Doppler on wheels, a little bit and what it is that you do inside of them during storms?
Sit in front of a computer.
Yeah.
The Doppler
watch cat
wheels,
videos. Yeah,
watch cat videos. Well, it's funny. Every time I bring kids in there for sorry, real quick digression. Every time, you do an outreach with kids and stuff, they're always like, do you have video games on here? Like, can we watch YouTube on here? And I'm like, you're in like a multi-million-dollar radar truck.
Kind of is one. Yeah.
Solitaire.
And they're very fascinated with being able to have internet or play a video game.
That's so great.
But yeah, no, I mean, they're radars. So how you conventionally think of a radar, how you think of, your 88D radar, although they're better. But I mean, it's, it's that on the back of a truck. So we have, a lot of different capabilities. We're X-band. 3 of our trucks are X-band. 88Ds are S-band, which means they're 10 centimeters. We're smaller. We're X-band, which is 3 centimeters. Only saying that because it affects some things. You attenuate worse, but you could also get your radar truck down the road. We have special capabilities. We could scan fast. So we scan up to 50 degrees per second, which means it would just take us 7 seconds to do a 360.
Wow.
88Ds or other trucks usually take, about 14 seconds to do that. And I know that sounds trivial, but when you're looking at hurricanes and tornadoes, a lot's happening during that time period. We could do really short sampling. We're able to do that. And then we have a special design now. They're dual pole, but they're also dual frequency. So still X-band. But the cool part about the dual frequency is that there's several different things like reflectivity or differential reflectivity. In order to usually get good measurements, you have to scan slowly, just because of the way it works. But if you have two different frequencies, you could scan faster because you're able to get more samples. So we're able to scan faster than other dual pole radars or most other dual pole radars because of that special design. And then we have a new radar, a C-band. So we built a C-band radar. So it's called the COW. And it has
not a Dow, but a cow.
Yeah, so it has a really big dish because it's a 1 degree C-band, and that one cannot get down the road. So basically what we have is the dish in two pieces, and we have a crane, and we assemble it in a couple of hours on site. So not really for tornado chasing, but maybe for hurricanes, but also, maybe for other sort of supercells or other sort of just, not quick type stuff where you could keep it up for a day and then move it the next day.
Wow. That's incredible. And most people's experience with radar or Doppler radar is on TV with a weatherman explaining, what they're looking at, what they're seeing. Obviously, those are static radar. What is the advantage of being able to take a radar into the field and for it to be mobile like that, like the Dows and the cows are? Yeah,
lots of advantages. I mean, the first thing is you could, go and get whatever you want to get. I mean, sorry, that was really, really good words there. If you're studying tornadoes in Colorado, you don't have to stay in Colorado to study tornadoes. You could take the radar to the tornado. So you could study the phenomena. You could take the radar there. You don't have to wait for it to actually pass by a stationary radar. The other thing is that you could get really close to what you're studying. So that increases your resolution, and you're able to see things a lot better when you can get, really close. Sorry. I used to do that with my face, but I just am not going to do anymore. But, the difference between seeing your hand back here and, seeing it, up close and personal, it makes a big difference in terms of the details you can see.
That's obviously the primary concern of y'all's studies is to get the clearest image of the weather phenomena. What are some projects that you're currently involved in or ramping up for to get close to weather?
Currently, nothing. Previously, we did some hurricanes this fall, and we also did some fires this fall in Colorado during the fire season. And then we're hopefully ramping up for a project that's going to be in the Southeast United States next year called Perils. And please don't ask me what it stands for.
We won't.
There's a lot of good acronyms out there.
Yeah, something about propagation, rotation, and linear systems.
What does it stand for? I'm just kidding.
But if you've heard of, there's been a project funded by NOAA called Vortex Southeast. This is going to be partnering up with NOAA and hopefully partnering up with NSF, the National Science Foundation, to bring down additional instruments, bring additional people into it, and really do this big project studying tornadoes and the systems that produce them in the Southeast. And by studying tornadoes, I should say not in the same way you do in the plains. I mean, you can't get up and chase and do that kind of stuff.
Right.
So instead, it's sort of a backed off deployment where we deploy, a couple hours before the event and let the event pass through our net. And we're trying to look at the storms down there because they're not, I mean, obviously there are supercells down there and supercells are making it, but it's not these nice kind of neat, supercells you get in the high plains. It's more of this grungy, which one is going to be a supercell or, what part of this line is going to make a tornado? So there's a lot of questions about tornado formation and the storms down there.
Yeah. Well, I'm really curious about when you said y'all were surveying and do some science with fires. What are you looking for in that specifically?
Well, some of it's just looking at what we can see. So there's been very little radar observations in fires. There's certainly some people in Nevada and California that, are pretty experts on this. But we've been trying to look at mapping out some of the places that the fires are growing. So on the radar, what you see a lot more reflectivity or a lot more power coming back. And you could see a lot of times these hot spots, or if the fires jump somewhere, you're able to see that. And especially in mountainous terrain, your 88D or conventional coverage isn't very good near the ground in places, like Estes Park or, up in the mountains there.
Yeah.
So we're able to
we're
able to get really close to it and get into the terrain. So we could see these small scale details like that. We could also see wind shifts and stuff like that. So we could see if things are, if there's any wind shifts induced by these fires. And then also you could look at the composition, and probably that could tell you something about the fire. If it's a lot of ash or, what actually is making up the different areas that you're looking at.
It's fascinating.
Yeah, and that just really displays the power of radar in general, right? It's like an MRI for nature, kind of. You're
Exactly. Yeah.
and you're getting a look inside these phenomena and to learn about them, because we just still, I think over and over, the more people we talk to and the more we experience, right? There's just so much still that's a mystery with all weather and things like that. Are you intrigued by the mystery of weather? Is that something that you feel like drives you to kind of want to get out there and study these phenomena?
Oh yeah, totally. I mean, that's the one thing I love about radars. I mean, I'm sure everybody loves something about, their favorite instrument or modeling or whatever, but I love that, like, even, whatever project we're doing, even if I'm not, the scientist on the project for my research, I'm just providing the radar. I love just like looking at, what somebody's going to go off and study. I'm like, oh yeah, that is really cool. Like, yeah, like that's awesome. Like, I didn't know, like, inside, like, whatever mountain snowstorms, that's what it looks like, inside, or that's some of the processes that are happening. So yeah, I mean, whether it's my research or sort of somebody else's, it's just cool to see the radar imagery and see what the radar is seeing.
It's cool. What's,
I'm
sorry,
ahead,
Jeremy. No, Jeremy, you go. You got better questions than me all the time.
Oh my gosh. What are some highlights in terms of, with tornadoes specifically, that you've set out to study, got set up next to a nice supercell that produced a tornado, collected some really nice data? Any stories in particular that have come back where you're like, oh, holy crap, like that's what's happening here?
Yeah, so tornadoes are tricky. And I mean, a lot of the sort of fast, I'll say high impact, quickly evolving and quickly dissipating weather it's always tricky to get exactly what you want, So, I mean, you always have an experimental design and you always have something that you're trying to get out there to get, whether, it's trying to map out the low level winds really close to the surface or how that relates to damage or how the tornado formed. I can go through a huge list of sort of the science objectives anytime you're out there. And ultimately what happens is, the deployment half works because, you're trying to get in a really precarious spot. The tornado dissipates or you can't get in that spot for some reason. So it's kind of fun to see then what, it's sometimes you're not getting exactly what you set out to learn, but then sometimes it's like, oh, but we have this and we could look at, we could look at this instead or, something like that. So for example, it's really hard. This low level wind thing has been really hard to get all these nice, great data sets. And we have a couple, and you have to just keep going out and doing it and trying. But it also turns out we've been getting a lot of thermodynamic data, which I've just been ignoring because I just want to care about winds. Like, yeah, whatever.
Give me the winds.
Yeah, winds. But then, actually, sitting down, I'm like, wow, we have a lot of thermodynamic data really near the tornado. And that's really important because, you talk about the temperature of these downdrafts and this generation of vorticity and convergence. So, we're starting to look at 7 or 8 cases, of this and not just one case.
Wow. That's such fascinating, like one ingredient, right, in the cauldron that makes a tornado, right?
Yeah.
And you mentioned low level winds, right? That's you're not the first person that we've talked to that is trying to kind of collect that holy grail of data in tornadoes.
Who's the other person? No, I'm just kidding.
We'll tell you after the podcast. No, I'm just kidding.
No, it's fine. I'm kidding.
We'll give their address.
It was a non-podcast conversation.
Yeah. Tell us why low level wind data? Why is that sort of a kind of a gold medal in terms of understanding tornadoes to you?
Because, I mean, we just don't have that information. So, all these, everybody's, I'm sure, familiar with the F or the EF scale, the Fujita scale, the enhanced Fujita scale, and that's all damage based. And that's sort of your very smart engineers, best guess based on looking at lots of damage and based on wind tunnel studies and, numerical modeling studies. But that's not based on, actual wind measurements and actual wind properties in the atmosphere. So how tornadoes do damage, whether it's switching wind direction, whether it's the duration, whether it's I mean, debris loading. I mean, there's all different ways they could do it. But again, we don't really have that profile of what's happening at house level. So what happens with a lot of at least the research stuff is that you get, observations 40, 50 meters above ground level, but you're not getting the 10 meter above ground level, which is where your house is. So one of the things that's interesting too is, if you're getting these 40, 50, 100 meter observations sort of regularly, how does that map down to the observations that you're not getting? Is there some relationship, you could apply for something that you're getting quasi regularly to what's actually happening at your house? So it's tricky. It's really hard. In order to get that, you have to be really close to get 10 meter observations. And the times that we've gotten them has either been somebody driving into the tornado or, it's a weak tornado or something sort of comes together for it to happen. But it's really rare and really hard to get.
Wow.
I have two different instances I would love to ask you about. I would love to hear what your observations were with the El Reno, Oklahoma. That's May 31st, 2013. Is that right?
It sounds about right. It was 2013. Yeah.
Okay. Yeah. So, were you there? And if so, what were some of the observations there? Because that was, I mean, for those of you who are listening, and you may not know, that it's considered and documented as the widest tornado in world history, and the winds were exceptional. So, what if you were there? What's something that comes to mind?
Yeah, I was there, and what comes to mind was it was a total cluster.
Yeah.
It was a really hard storm to deploy on. So I guess, to give context for anybody who was out chasing that season, I think the week before, maybe, or the 2 weeks before, there was the Moore EF5 tornado that had come through. And during that, however it worked out, people actually were able to evacuate. So they were given, whoever the meteorologist, their whatever station, he had kind of told people to evacuate, or people did evacuate. And people actually sort of did successfully. The Moore, Oklahoma tornado is sort of a very classic tornado. And we were down south, and every other research team was down south. And it's funny, we got to an intersection, I remember, and we're like, should we go north or should we go south? And we're
Jeff and I had the same experience. We were down with y'all down there too. Yep.
And then we're like, oh, it's not going to be making a tornado if we go north. Like, it'll be done by then. And it was still making a tornado. But the reason I was giving this context. So the storm was really confusing. So we were there and looking at the radar data. There was an anticyclonic tornado. It was a very big tornado. It was dark by the time we were doing the deploying on it. It was really, it was just a really confusing circulation. So I was watching the radar, and we just didn't really know what to do with it. We didn't know how to get a good deployment on there. So we decided we were going to go east a little bit. I mean, we were deployed, we were scanning, but we weren't, feeling, the most comfortable, and we're like, and we started going east, and we got evacuation traffic. So people were contraflowing for this tornado. So people were,
wow.
Yeah. So we're going east to get ahead of this, and people are evacuating to get south. And it was also rush hour. And, luckily what ended up happening is the tornado dissipated sort of right when it was getting towards these main roads that people are evacuating on.
Yeah. The highways.
But I mean, otherwise, it was just, it was a mess doing that. And then it was also creepy because when we were driving, and again, I was watching the radar and my colleague was up front, and it was dark. All the debris from Moore had been piled up in one of the parking lots, and it was windy. So it wasn't making a tornado anymore, but it was really windy. It was starting to surge. So, the winds were, still 70 or 80 miles an hour, but it's picking up all this debris from what was piled up from Moore. And so my colleague in front's like, come on. He's like, really? There's no tornado? And I'm like, there's not a tornado. And there wasn't. It was, at that point, it was just surging, but it was really freaky because it was confusing, at one time. Then there was this evacuation traffic, so we were trying to get out of there.
And PTSD from 2 weeks earlier. So
so it was really confusing. So we did get data in it. We got data with two of our radars. And again, it was a very big circulation. Tornadoes, as I always tell people, come in different flavors. So in some ways, no two tornadoes are the same. I mean, sometimes you get these nice simple couplets, and sometimes they have all these multiple vortices, and they're big, and the RFD is doing weird stuff. And in this case, it kind of was that. And they had all these multiple vortices kind of going around. And the tornado itself, or if you call it a tornado, was just really big. So I think people were getting confused where the circulations were coming from. So like the Weather Channel, for example, I think they were kind of confused just because I've seen these videos, not, and it would be confusing, I'm sure, visually. I mean, it was confusing on the radar. We didn't know what to do with it. And I think, Tim Samaras, I mean, obviously I don't know what they were thinking, but yeah, I mean, again, everybody ended up in this sort of big, mungy, huge circulation. And then in this big, mungy, huge circulation, there was all these small ones going around. And some of them were going incredibly fast. So the wind speeds associated with them were incredibly large in these small little vortices that were going around the main circulation.
Did you guys get any readings from the smaller vortices?
Yeah, so we did an analysis where we mapped out looking at what happened to Tim Samaras with our radar data. And he was impacted by one of these smaller vortices, and it had incredibly strong winds in it, over 300 miles an hour.
Wow.
Yeah.
Gosh.
So.
Yeah, and you talk about you were talking about before with the EF scale and how that's damage, right? Related, right? That's after the fact. Looking at what a tornado does to an area, to structures, to things like that. That's common to other studies that have been done in the past, right? But you get to look at the real time wind data and how that's a different set of data. And in kind of the weather community or the severe weather community, there is a little bit of like, should we be using, wind speeds or recorded wind speeds to classify these storms? I'm curious if you have any input or opinion on like where do you think tornado classification is going or should be going in the future with the new data?
Yeah, that's tough. I mean, the National Weather Service has to decide. I mean, they're the ones who really decide what can or what goes into their database, what they use or what they don't use. So I think what there's been a big push for is just using all data. I mean, I don't know how that ends up, and then keeping kind of all data for stuff or keeping all kind of numbers for things. So if people are going back, years from now, and have better relationships or better ways to, do this stuff that besides damage stuff, that you do get, the Doppler on wheels measured at 310 mile an hour, that, and then you have that type of information too. So I think and even you could do forensics after the fact with trees and all different sorts of stuff. So I think the push I think right now is just to make sure that that information gets kept in the storm database. And then, like I said, so going forward, if things decide to change, no measurement's perfect, obviously, and no way of doing it's perfect. Obviously they all have limitations. So
I have one more storm instance to bring up, and that's Dodge City, Kansas. So we've watched a video that kind of unpacks some of the difficulties of that day, and I was chasing that day, and I remember, and I've told the guys that of all the chases I've ever done, mud was the thing. I've never encountered mud like that. It just made me hate roads for the rest of my life. But what a unique outbreak that was. And I know that y'all had one pod that was hit by a small tornado, but what jumps out to you about that day in particular?
The mud.
Yeah, it's fair. That's fair.
The mud.
It was so bad.
Yeah, so Sulphur, which was earlier in the season, we had a pod hit by the periphery of a tornado. And then Dodge City, we had a pod hit by a tornado, which is good. So those were actually two really good things. But for the radars, and both of those ended up being slightly unideal for different reasons. But for Dodge City, I was in the radar that slid off into the ditch.
I was close to y'all when that happened, so I get it.
And then the other radar and the tow strap, and then it was dark, and I don't know. So I was just scanning in from the ditch. But I mean, we kept scanning through the entire lifetime of that tornado, and it was an interesting tornado. It had a cyclic tornado genesis thing that went on, and it definitely had a lot of different structures going on. So it was a pretty cool evolution. And again, we also had pod data.
That is really fascinating. And for our listeners, we talk about videos a ton, and we know this is an audio medium. And so all of our videos will be, that we're mentioning, will be in the show notes. Oh, no, don't be sorry at all. We do it all the time. But yeah, the one video in particular, really, of you sliding around in the mud, it really gives a great image of like just how beastly the DAOs are. I mean, they're like 20,000 plus pound monsters, right? Like, and so on that like frictionless surface, it's pretty wild to see. And that's so rad that y'all kept scanning. Like that feels like very like badass science happening. Like we're going to keep scanning. We're going to keep scanning. We're going to keep doing science out here. And you mentioned a little bit before, obviously you're not the only person out on the field, doing these things. And the DAO isn't the only instrument that you take out. What are like the spectrum of like numbers of people that can be involved in projects that you're involved with? And like you mentioned pods and things like that. Like what are some more, instruments? It's kind of like a small army that goes out with you, but like, yeah, I don't think people understand that, these are pretty big projects.
Yeah, well, it depends on the project, depends what we're trying to do, and depends on how much money we have. And again, I try to, hurricanes and tornadoes, it's almost like you have to just keep doing it to really get the data. So sometimes, sometimes it's just 5 of us going out there, or 3 of us going out there, with a truck or with 2 trucks. And then, some of these bigger projects, could have like 100 people out there doing this type of stuff. So like a Vortex 2 or like a Pecan, or for Lampico probably didn't have quite that many, but that's, a larger project with a lot of people out there. So some of these projects, we have 3 radars, 4 now. Other institutions have, radars as well. So, you can get upwards of 12 or 13 mobile radars out there.
Wow.
Things that I was talking about, pods, these are basically ruggedized weather stations. We have 25 of those. Other institutions have, similar ruggedized or weather stations that they deploy. 20 or 40, I think they have now. So you can get,
wow.
a lot of those out. Sounding systems. You could just, get 10, 20 of those out too. So you can get a lot out there.
Seriously. And then you have, they're called mesonets, right? Are they, what are mesonets?
Really cool vehicles. They're pickup truck. Ours are pickup trucks. And basically we have a mast that's about 3.5 meters high that have instruments on it. So the idea with mesonets is that they're actually targeting something of interest. So I talked about RFDs and fronts and stuff like that. So a lot of times mesonets would be driving through those, looking at temperature gradients, looking at wind gradients, and looking at moisture gradients to try to get this fuller thermodynamic picture.
Wow. Looking back at yourself, what we talked about at the top of the episode of you, kind of coming into the field, I'm curious, like, how would you encourage yourself, or what advice would you give yourself coming into the field now that you know?
Yeah, I don't know, because it ends up depending on what you want to do. So I always feel like, what advice would I give myself now?
Yeah.
I don't know. Yeah, I don't know. You sort of just follow a path, and I don't know, things sort of change, as you keep going along. And like I said, it sort of depends on what you want to do. And don't get so discouraged.
Yeah.
Well, that sounds like the process that you took was you kept grinding until something really popped up and kind of grabbed a hold of you. And then that's the direction you went. Does that sound right?
Yeah. Does that sound really not planned out?
Yeah. I think
that's life. Yeah.
That's life. That's accurate. That's real accurate.
I think it's honest.
I'm glad you said that. Because a lot of people have like my 10-year project, my 20-year idea. But sometimes you're just going through it going, oh, wait, that piqued my interest. I'm going to go that way now.
Yeah.
And I think it's really riveting and liberating to hear that, to be honest with you. So I appreciate you saying that.
And I think that's encouraging too for young people listening to who may be interested in meteorology or any of the sciences, right? It's like, not everybody has the same trajectory, and in any pursuit,
Oh yeah, for sure. Some people are already, passionate. They totally know what they want to do. And like you said, they have a 5, 10, 15-year plan, and that's fantastic, and yeah, I mean, I feel like in that way, you'd probably give yourself better advice. That's what I was saying. I'm like, I don't know. I'm like, I just kind of keep like, shoot, like in order to make a radar work, I need to, make sure I know how to do this, and then I'm like, all right, I got to learn how to do that,
Oh, that's great.
So.
Well, we really look forward to, just us guys look forward to seeing kind of what you guys keep finding, and even just the questions y'all keep raising and the hypotheses y'all keep raising. We find it just so fascinating. And I know I personally, this may seem silly, but I'm kind of, whenever I see a DAO out in the field, I get really like lots of warm feelings, and like super appreciative that y'all are out there, A, because I know I'm probably in the right spot, to see something.
Yeah, it's verification for us. Yeah.
And so I'm thankful. And B, I'm just like, thank goodness y'all are out there, paying attention, collecting the data, and doing this work, because it is, who knows what your data will trigger down the line, what other hypotheses it'll trigger down the line. And I'm thankful to see science being done. It's rare to see it actually being done. So
Yep.
I was telling the guys, I was texting them earlier, and I was like, I kind of find the DAOs a little sacred. Like, I'm just kind of, maybe that's silly, but as a star chaser, I kind of am like, I get sentimental about it.
I wanted to show you something. I was watching you did a TED Talk. It was like a TED Youth Talk.
That was great.
I think it was 2013.
It was really great.
I was
only
watching it.
because I wasn't, sorry, real quick. I wasn't even thinking when I did it in Louisiana, and I'm like, I'm going to talk tornadoes. And I'm like, or I could have talked about
It's just like,
hurricanes. Yeah, I'm like, or I could have talked about hurricanes.
What's a
and like, which is
tornado?
probably more, yeah.
But I was watching it, and my 9-year-old daughter came and sat on my lap, and she was just soaking it up. And she, as soon as it ended, she hopped off my lap and disappeared. She came back with this about 10 minutes later.
That's
It
awesome.
says, for the listener, she drew, to her best of her ability, a hook echo.
It's really good.
It's
It almost
really
looks like a
good, yeah.
hurricane in there, yeah. But I just wanted it, like, it sparked, like, it just gave me, like,
Aw.
just for her to see a woman in STEM doing her thing and standing up, like, on the stage and presenting scientific research, and just someone who's passionate about what they're doing. Do you have any advice for especially young girls who want to pursue a STEM career?
Yeah, I mean, I say do what you want to do. I mean, just do it. I mean, that's sort of in my, yeah. And don't let people, I mean, you're always going to get discouraged by people, but don't. There's always good people out there. You're always going to find, you will always find your people, I think. If you're sort of doing what you want to do, you're going to surround yourself with the people, I think, that will lift you up as well. And just, I think that's true, just regardless.
That's great advice. And yeah, I'm reminded, you said this earlier at the top of the show. You said, you said you kept working with people you wanted to work with.
Yeah,
And that's
true.
a beautiful thing.
Yeah.
Yeah.
And people have so many different talents too. I mean, it's also, appreciating, everybody's different talent, what everybody's bringing to the mix. So, I mean, things that, I'm not so good at, I mean, I'm certainly working with people that are, better at those things, and that's fine, and hopefully I'm bringing stuff to the table too. But yeah, I know for people pursuing, for kids, students, anybody, I mean, no matter where you are, I mean, I think just, like I said, just do it. But again, it does make it easier when you surround yourself with the community that's helping you.
Yeah,
and you're
absolutely.
helping.
That's great life advice. Yeah. Awesome. Well, Dr. Kosiba, thank you so much for joining us on the Tornado Trackers podcast. We find your work just so utterly fascinating and compelling. And well, that's going to do it for this episode of the Tornado Trackers podcast. Find us everywhere on the web at Tornado Trackers, youtube.com/Tornado Trackers. We've got a whole load of amazing videos on there, shot primarily by Jeff and Gabe. They're incredible videographers. And you can do another thing too that would be really helpful to us. Rate and review us on Apple Podcasts, and in that review, share the weather story that means a lot to you, or maybe a lot to your family. We would love to read those on the show. We find those kind of endlessly fascinating. That's another episode of the Tornado Trackers podcast. We'll catch you in a couple weeks. See ya.